Hey guys, welcome back. So in today's video, we're going to be working with the 15th problem in the Leetcode problems, and that's called threesome. And so the idea of this is if we're given a list of called nums with various numbers, we want to return a solution set that has all unique values of which the three numbers add up to 0. So in this case, -1 plus 0 plus 1 add up to 0, -1 minus 1 plus 2 add up to 0. And so we just want to return triplets that add up to 0. And they say that they cannot be duplicates. And so that is what the threesome problem is. I created a Google Doc here. They call it threesome. Call it threesome. I can type it right. Self nums. And so now the basic concept is going to be that if we're given a list like this, the first thing we want to do is we want to sort it. And so we're going to call the nums.sort method so that we can sort our integer in the way we want. And the next thing we want to do is we want to loop through every number and look at the rest of the array and see which pairs add up to 0, or which triplets add up to 0. And so in this case, the concept will be that if we look at actually, let me print out, I'll return none here. And so I'll nums.sort and then I'll print nums. So this is, I'm just doing this quickly so that we can see a sorted version of this nums example right here. So this is a sorted version here. And so the concept will be if we look at the -4 first, that's weird. If we look at the -4 first, we have our -4 on the side. That leaves the rest of the array to be -1, -1, 0, 1, 2. And so what we're going to do is we're going to look at the first and last numbers. So in this case, our 2 and our -1. And we're going to see if, in this case, since our number is -4, 0 minus -4, 0 minus -4, wait, -1, I'm missing a number here, 0. -4, 0 minus -4 is 4. And so this means that in order to get to our target of 0, the other two numbers that we find have to add up to 4. And so what we can do is if we look at the first and the last numbers, -1 plus 2 add up to 1, which is not equal to 4. But the key thing we should know in that point is since the sum of those two is less than the target, which in this case our target is 4, then we want to increase our number. And so we look over here, since our -1, it's still -1, then we still can't find a triplet because again -1 plus 2 is 1, and that's still less than the target. And so since 1 is less than our target, we want to move our low index over. And so we look at our 0 plus 2 is 2, which is less than 4, so we want to move our low index over one more. 1 plus 2 is 3, and that's still less than 4, and so we want to move our low over. And so we want to keep going until our low index is less than, we want to keep going while our low index is less than our high index, because we can't ever get to a point where we use the same index 2 times, because we don't want to return 2 and 2. 2 plus 2 is equal to 4, but since it's using the same number at the same index, we can't use that as part of our triplet. And so in that case, now that we've looked at our -4, we can look at our -1. And so instead of our 4, we're subtract -1. And so that means our target is now 1. And so in this case, I can get rid of it. And now we're looking at this part of the string, the rest of our array. And so in this case, we look at our cases, -1 plus 2, that adds up to 1, so that we found a triplet right there. And so we can append that, and in that case, we can increase our low index and decrease our high index. in this case 0 plus 1 is also equal to 1, so we found another triplet. And so in that case we increase our low index 1, so our low is here and our high is here. But since our low is greater than our high, that means we've either met at the same point or we've crossed it. And since we don't want to keep checking if we cross, because that means we've already checked the combinations, then we can just we're done with dealing with our -1. And in this case, one thing we want to make sure is we don't want to keep repeating and checking for -1, and so we want to keep looping over until we get to a number, until we get to a new number. And so in this case, our new number is 0, and if you can see 0 minus 0 is 0, so our target would be 0. 1 plus 2 is 3, so that doesn't add up. And so one thing we can note is that if we ever get to a point where the current number that we're on, this number, is greater than 0, then we can just return right there, because since our nums array is already sorted, if we get to over 0, then we can never get back to 0, because you can't add positive numbers to get to 0. You must have negative numbers. And so in that case, we can just return right there and return our output. And so hopefully that kind of made sense. Let's start coding it up. And so the first thing I'm going to do is I'm going to do nums.sort to sort our array, and I'm going to say output is equal to our or I'll say triplets is equal to an empty array. And so now what this is going to do is what we want to do is we want to look at our first array. And so I'm going to say while nums I, or I have to initialize a variable called I equal to 0. So I is going to be the index that we're currently on. So while nums I is greater than 0, what we're going to do is that we're going to say our target is equal to our 0 minus nums I. Our low is equal to our I plus 1. And so what this is doing is, if we're looking at our very first number here, we want our low index to be at the index that we're on plus 1, so that we're looking at the rest of our array. And then we're also saying we want to say that our high is equal to our len of nums minus 1, so that the index of our very last number is the length of our numbers array minus 1. And so we get to our last array, and I believe that should be it. And so we can say while low is less than high, if nums low plus nums high is greater than our target, that means well, first actually we'll check if it's less than our target, because that's one of the examples we looked at. If our sum is less than our target, we want to increase our low. If our nums high is, or if our nums low plus nums high, if our sum is greater than our target, we can move our high index down, because we want to, since our numbers are sorted, we want to make our sum smaller. That is not our high minus equals 1, so we want to decrease our high index by 1. And if we get to a point where we found a spot where our sum is equal to our target, we can say our triplets dot append our nums I. So we want to make sure this is in order, because if you look at the examples here, it goes -0, 1, -1, 0, 1, -1, -1, 2. So those are in numerical order. And so all we need to do, we can just put these in numerical order. Since our nums I is going to be our smallest, our nums low will be our middle, and our nums high will be our biggest. And then we can increase our low. So in this case, what we want to do is, now that we're moving on to our next number, we want to make sure that we don't keep repeating the same integer. So if we look at -1 and 2, we don't want to look at -1 and 2 again. And so, or we basically don't want to be looking at the same numbers again. And so I'm gonna say while nums low is equal to our nums low plus 1. We want to keep increasing our low index, so that basically if we're looking at 3, 3, 3, 4, and if we're on this this index here, if this number is equal to our index in front, then we want to keep moving along. This one is equal to our 3 in front, we want to keep moving along. This one is equal to our 3 in front, we want to keep moving along. At this point, since this 3 is not equal to the number at the index above, that means we're at this low, our low number is at this index. And then what we want to do is we just want to say low plus equals 1. And so also we want to make sure while low is less than high, so that we don't cross the border, or cross out, we don't cross. And then we'll do a similar kind of thing for our high. If our nums high is equal to our nums high minus 1, we want to keep decreasing our high index, and then at the end we want to keep decreasing again, because if we move our 4 to the front and we're over here, our 3 before is equal to this 3, so we move back 1. 3 before is still equal to, our 3 is still equal to the 3 before, so we move back 1. This is still equal to the index before, so we move back 1. And at this point, our 3 is not equal to the number at our index before, so we don't move back 1. But since we're on this index and this is still the same number, we move back 1 more time, so that we ensure that we're on a new number. And so that's traversing kind of the remainder of our array. What we want to do is, once we get all the sums, get all the triplets for this one target and this one nums I, what we want to do is, I think it's lined up. What we want to do is we want to make sure that if we look at -1, once we check for this -1, we want to make sure that we don't look at it again. And so what we'll say is while nums I is equal to our nums I plus 1, we want to move our I plus equals 1. So we keep moving our I index along so that we can get to our new number. So if we're on this one here, we move it along, and then once we get here, we want to once again we want to move our index over 1, because we ensure that our next number is going to be a new number. We just have to nudge it over once more. And so I plus equals 1. And so while nums I is greater than 0, that's that. And so if we ever get to a point where the new number that we land on is greater than 0, no, we want to say while nums I is less than equal to 0. So if we get to a point where our nums I is greater than 0, then we can just end our while loop right there. So it's going to fail the while loop, and at that point we can just return the triplet sums. And so I believe that is it. We'll go over it one more time to make sure. So we start off at our first index. We check to make sure that our nums I is less than or equal to 0. We make our target, initialize our low and high, while low is less than high. If the sum is less than target, we move our low up. If it's greater than the target, we move our high index down. If we find one that fits right, that's equal to the sum and target, then we append it to our triplets array, and then we keep moving our low index up so that sorry, I'll delete this. We keep moving our low index up so that we don't keep encountering the same numbers, and we move our high index down so that we don't keep crossing the same numbers. And then at the very end, while nums I is equal to our nums I plus 1, we can just we can just move our I index over. And so that ensures that we have to add another edge case here, while and I is less than len nums minus 1. And so what this makes sure is that we don't get to our we don't go past the end of our array. And so that is that. I feel like there is a better way we can handle for this, which I'm thinking what we can do instead is we can just increment our I index 1. We can just increment our I index 1, and over here what we can say is if I is not equal to 0 and our nums I is equal to our nums I minus 1, we can just continue. And so what this is doing is we're saying that if the index that we're on is not 0, so it's not the first number, and the current number is equal to our previous number, we're just continuing. So we're not even going to run any of this. We're just going to go on to our next iteration. And so that will hopefully I'll hopefully run. I'm thinking we should probably increment our count here also, plus equals 1, because it's not going to run any of this, so we have to make sure we increment our count here. And so that should do it. We handle for all of this, we increment our count, and that should be it. Like, we can start typing this into our Leetcode editor here. Triplets are equal to our index is equal to 0, while nums I is less than equal to 0. If I is not equal to 0 and nums I is equal to our nums I minus 1, we can say our I plus equals 1, continue, and if that's not the case, target is equal to 0 minus nums I, low is equal to I plus 1, I is equal to nums minus 1, while low is less than high. I'm going to say if nums low plus nums high is greater than our target, then we want to decrease our high index. Else if nums low if our nums is less than our target, we want to increase our low index so that we can make our number bigger. Else we can say our triplets append nums I, nums low, nums high. While nums low is equal to our nums low plus 1, low plus equals 1, low plus equals 1, while nums high is equal to our nums high minus 1, high minus equals 1. We want to make sure we add our minus equals 1, and then at the end we just want to increment our count by 1. And leave at the end we can return our triplets. So let's run this on the test case that we have, and hopefully this will work. So we return the numbers, the triplets that we want. There's no other cases, so one thing we will want to do that we should handle for is if the length of our nums is less than 3, then we can just return an empty array. And so because we can never have 3 numbers anyway, so that handles for that. So if I run this and I run the code, it should return an empty array, which is what we want. And so it does that. Try another test case. That adds up to 0. We have to wait a couple seconds. We return the -0 and 1. We'll see. Let's check -5. So we return nothing, and then we'll just check with the 5. Return nothing. So I'm gonna hit submit, and hopefully this will pass all of the Leetcode back checks. So last executing, but 0, 0, 0. So what we have to make sure that we do here is we len nums -2. So what I forgot to check for is we have to make sure that we have to make sure that there's always 3 numbers we can check. And so if we get to a point where we have 1, 0, 2, 3, 4, I know we can't get a pair out of this, but this is just an example. If we have to make sure that the last number we check is this, because once we get to the 4, there's no way we can make a triplet, and so there's no point of really checking that. And so the way we can do that is by getting the length of our nums array and just subtracting 2. And so hopefully if I run submit, that should fix the error, because we kept increasing our index, and we never checked to make sure that we got past the array, or where we're at in the array. We want to make sure that we don't get past the end. And so over here we see that our function works. And so sorry about that little check there, but this is how we can code up our 3-sum function in Python. Hopefully this helps you guys, and until next time, alright, see you guys later.